Hello, my name is John Cahoon. I'm the forester with the Genesee Conservation District. And today we're going to go over a presentation about the Gilkey Creek Subwatershed Survey that the Genesee Conservation District conducted in 2022. So the goals and objective of this project, first of all, were to survey the impervious surfaces within the Gilkey Creek watershed, just to kind of get an overall understanding of how much impervious surface the watershed had and what effects those surfaces might be having on the health of the Gilkey Creek. Beyond that, we conducted a stream survey of Gilkey Creek that involved actually going out into the stream and measuring conditions of various forms of non-point source pollution to assess one, the actual impacts that we can measure that we think impervious surfaces might be having, but also two, to serve as a baseline for future work so that we can have a better understanding of where we're at and kind of what changes we've made over time. And then for our presentation today, we'll also touch on some of our findings and some recommendations that the district has on how we might be able to improve the watershed moving forward. And then we'll just leave you with a couple of final thoughts. So impervious surfaces within the Gilkey Creek watershed. This map, as you can see, it lists a variety of impervious surfaces in that legend up there on the right-hand corner of this image. So I would like to point out that this initial survey was conducted using the U.S. Environmental Protection Agency's GIS layer for the Gilkey Creek subwatershed, which also includes portions of the Flint River watershed that just happen to be very near Gilkey Creek. So some of these properties that are listed here on the right are actually on the west side of the Flint River here. And so those properties were not included in our study, although they are included on this map, only because those properties wouldn't drain into Gilkey Creek directly, and therefore they wouldn't really contribute to the condition of Gilkey Creek and wouldn't factor into the study that we've conducted for this particular project. So of the sites that we were able to identify and sort of delineate as being within the Gilkey Creek watershed itself, there are 4 large sites that we found that might be potential candidates for some green infrastructure. And then we found several other smaller sites that we'll talk about kind of once we get toward the end of this section. So the first large site that we found was a large former automotive manufacturing site that is at the corner of Dort Highway and Davison Road. So it's almost 60 acres in size. It's paved, but that paving surface is in generally poor condition. There's a lot of vegetation that's growing up through it. Potentially, this is serving as a cap to try to prevent some sort of contamination in the ground from leaching out. And so we don't know if de-paving is really a viable option here or not. But certainly there is the opportunity to do maybe some other sort of green infrastructure projects around the edges to try to create some riparian buffers and those sorts of things to mitigate some of that impervious surface. Given that this property was a former manufacturing site, there's is the potential that we have some sort of complicated histories here, and that going onto the site and doing any sort of work like this might not be something that the owner would be comfortable with. So the willingness of the owner of this property to participate in these projects is unknown, but that's not to say that it's not worth having a conversation with. Our second site is located along Avril Avenue and Davison Road. This actually happens to be right across the set of railroad tracks from the first site. Being in very close proximity, it's also in almost identical condition. It's not quite as big. It's only about 45 acres in size, but again, it's a former automotive manufacturing site. Service condition is poor. There's a lot of vegetation growing up through it. Potentially, this pavement is a cap. It's used a little bit less often than the first site, but it's still used occasionally, so it's not completely abandoned. Again, de-paving is likely going to be something that could aid in reducing the amount of impervious surface within the Gilkey Creek watershed, but we don't know what other unintended consequences work like that may have. And so without knowing all of the previous site history, really recommending what the best green infrastructure practice is a little bit complicated at this point. And again, because of that site history, the owner's willingness to participate is unknown at this time. Our third site is owned by Ship Up LLC. It's currently being used as the bus garage for the Flint Community Schools. The site's a little more than 6.5 acres in size. The parking area is kind of generally divided into two sections. There's a northern half, and then there's a southern half. The northern portion, on the aerial imagery from the Genesee County GIS website, it shows that this parking lot is in very poor shape, but going out and doing field assessments, we discovered that it had very recently been resurfaced, as in within the last few weeks or the last few months. And so kind of in the second half of 2022, this northern portion of the parking lot was resurfaced, making it really not a great candidate for de-paving as it has just been improved. But the southern half certainly is a candidate for some of that de-paving opportunities or maybe some other green infrastructure projects. Um, so it is still used. It's currently being operated as the bus garage, and so certainly those uses and those needs exist. And we're not advocating that we remove it entirely. However, given that the Flint Community Schools student population has gone down significantly over the last few decades, it's likely that they don't need as much space as they did in the past. And so there might be some opportunities to maybe de-pave some of the edges or maybe a small section of the southern portion of the parking lot, and then install something like a rain garden or other green infrastructure, try to capture some of that stormwater runoff before it were to enter Gilkey Creek or the storm sewer somewhere else. So we think that in that regard, the suitability for some de-paving work or some green infrastructure work is kind of moderate to high. Additionally, because the owners of this property are sort of directly tied in with the Flint Community Schools, we feel that there is an opportunity to draw on some community buy-in, and that would likely increase the chances that the owner would be willing to partner with us on a project like that. Particularly if we were able to get some outside funding to make this project sort of cost neutral for the owners of the property. Our fourth and final large site that we were able to identify using aerial imagery is actually a former cinema that is located on Court Street, kind of between Flint and Davison. It's actually technically it's between Genesee Road and Belsey Road along that Court Street corridor. So this, like I say, it was a former cinema. The area is actually about 17.5 acres in size. It's a paved surface, but that pavement's in generally pretty poor condition. The use is kind of low to moderate. It is fenced, and there are cars and vehicles that are parked back there, but it doesn't look like it's a particularly highly used space. And we feel that our return on investment for green infrastructure work on this site would be the highest of all of the large sites that we identified, because Gilkey Creek has a north branch, and that north branch actually runs through the center of this property. So if we were able to improve this property, it would have direct impacts on the creek. And additionally, the neighbor of this property to the north and to the east is actually an agricultural property. It's a farm. And if we were able to install some green infrastructure to buffer some of the agricultural runoff off of those properties before it made it to the creek, we feel that would have very significant positive impacts on the Gilkey Creek waterway. So because of those things, we feel that our suitability for de-paving and other green infrastructure work is high. And although the owner's willingness to participate in this project is at this point unknown, being a former cinema, it's unlikely that they're going to have the same challenges that may creep up in a project that was conducted on a former automotive manufacturing site or at a bus garage. And so comparatively, we think that this property probably has a much simpler history and therefore would be easier to facilitate some work on. We had about 21 smaller sites in addition to these 4 large ones that we did evaluate. However, most of those sites were between about 1/10 of an acre and about 1.5 acres in size. We had one of them that was almost 5 acres, but even those larger sort of sites that are within that smaller group, there's just not a lot of land mass there. And so the amount of work that would go into sort of coordinating that work and then trying to work with the landowners and those sorts of things likely is going to diminish our return on investment fairly quickly. And so our recommendation, instead of kind of pursuing a lot of smaller projects, would be to work on a few larger projects, namely at this property here on Court Street, to try to get the most bang for our buck in terms of resources that are going to improve Gilkey Creek. So our Gilkey Creek stream survey, this was kind of the other big portion of this project. So this was conducted for a few various reasons. This was conducted in December of 2022. So it wasn't really a high flow time of year for the creek, although the creek was certainly still moving. And I will point out here that you can see this is a map of all of our study sites. And our study sites range in number from 1 to 19. However, we don't have a study site 9. When this survey was originally planned out, the upstream side of site 8 and the downstream side of site 8 were separated into 2 different sites. However, the way that we were collecting our data, we were collecting both upstream and downstream of a stream crossing. And this is actually one continuous culvert. So once we got into the field, it was assessed that we should be running both of these sites simply as one very large site. So that's why we lost site number 9 in our study. And therefore, although we have 1 through 19 numbered, we actually have 18 sites along Gilkey Creek proper, as well as 3 additional sites along the Robinson Drain. So Robinson Drain begins quite a bit south of this map down in Burton. However, when it goes underneath Lippincott Avenue, it actually goes into a culvert, and it stays underground until it comes out very near the corners of Dort Highway, Lapeer Road, and I-69. So if you guys are familiar, if anybody's familiar with that area, it actually happens to be right behind the Taco Bell that's right there. And so it comes out of a culvert behind Taco Bell. Robinson Drain 2 is where it goes underneath, goes into a culvert to go underneath I-69 and the railroad tracks there, and then it comes out of that culvert over in Pierce Park, and then it flows from there west and a little bit north until it runs into Gilkey Creek. So that's kind of generally the area that are in the stream study encompassed. And these were the metrics that we were using to evaluate non-point source pollution within Gilkey Creek. Now, a couple of things that I do think are worth pointing out. Stream crossing is incredibly high, but that is artificially high because the way that we determined where we were going to conduct our survey points was by looking at stream crossings. So making sure that every point also included that sort of stream crossing component was kind of baked into the methods in our study. So saying that all of Gilkey Creek is a stream crossing is not true. It just happens to be an artifact from the way that we designed our study. But with that being said, stream bank erosion was found at every single site, and we do suspect is rather ubiquitous throughout Gilkey Creek, at least in the areas that we surveyed. Also to note, tile outlets were very common at most sites, and then less common, but still notable. There was a lot of spaces that did not have adequate riparian buffers. And then there were also a few sites that experienced gully erosion, and we had a couple areas that also were potentially impacted by road runoff. But we'll get into the finer points of that all here in just a moment. So in determining the severity of non-point source pollution, many of our data sets use a 1 to 4 scale to evaluate severity. And this I wanted to go over just this way everybody's on the same page and you can understand our numbers a little bit better. So the way that this scale operates is that we would, in the field, we would measure the vertical distance of erosion. So it doesn't really it's not concerned with how far back away from the center of the stream the erosion happens. However, it is concerned with the depth of the erosion. And then we divide that depth over how many years we suspect that erosion has been happening. And then if that value of height divided by years is less than 0.05, it's just slight erosion. Moderate is from anything between 0.05 and 0.25. Severe is anything between 0.25 and 0.5. And then very severe is anything greater than that. So that's generally the way that that number is calculated. Just so this way, as we're going through, if anybody has any questions about that, that's how that works. Our study design, we were using points to assess Gilkey Creek. We were not measuring the entire creek. We were just sort of taking samples. And so we measured upstream and downstream 100 feet from our stream crossing. And we confined our study to those parameters just for the logistics of having to go out there You know, like I say, stream erosion was rather continuous throughout the course of the stream, and so measuring how far did that go would essentially mean that we would be walking the entire creek. So everything except for the road runoff, which was something that we were able to evaluate using aerial imagery, all of that was confined to kind of 100 feet plus or minus our stream crossing. So stream crossing erosion, all the survey points, like I say, they were at stream crossing. So every location has this data. Um, this data measured um, a lot of information. It recorded what kind of a crossing it was. Some areas were bridges, some areas were culverts, some areas had double culverts. So kind of what does that stream crossing look like? Is the stream crossing paved? What is our approach material? So the approach is actually a very interesting thing, and we'll kind of talk about that on the next slide when we got an image to kind of work through that. And then it also recorded the condition of the culvert or of the stream crossing. It recorded the soil texture, and then also it went over some potential erosion locations around the stream crossing to really try to record exactly what was going on in that particular portion of the stream. So as you can see in this image, the approach is the area um, that is uphill of the stream crossing. So if you can imagine, you have a culvert here, and kind of picture. It doesn't really apply to the Gilkey Creek watershed, but if you can picture a much more rural stream crossing where maybe you have a very small culvert that's at the bottom of a valley and the road kind of comes up and it's perpendicular to the stream and it goes uphill in both directions. So the approach is, what is the distance between the middle of that stream crossing, so the middle of that culvert, all the way uphill to the top of that hill. So kind of how big is that funnel? If rain were to land on the road, how much roadway does it have to run down before it falls into the creek? So the approach is a measure that is perpendicular or 90 degrees to the path of the stream. The left bank and the right bank, that is always looking downstream. On our data set, on some of the data sheets, it asked that some of the metrics be recorded looking at the culvert. We decided that to reduce confusion, the left bank was the left bank all the time, regardless of what side of the stream crossing you were on, and the right bank was the right bank. So it is a little bit of a deviation from the way that the data sheets laid it out, but we were consistent throughout our study, and that seemed to be the easiest way for us to kind of keep track of what was going on while we were out in the field. And then the culvert, as you can see here, the culvert is the actual gray infrastructure piece that either channels the water through, or in the case of a bridge, it would be kind of the abutments on either side, and then the bridge that goes over top. So this is an example of a double culvert. This is actually the Robinson Drain 3 inlet side of that culvert. And so potential erosion sources, because this is the inlet side, so the stream is flowing away from the photographer in this image. So this is the left bank, that is the right bank. We didn't have road ditches at this particular location, but a road ditch would be sort of along this road, so they would also be going parallel with the road and perpendicular with the stream. So this is the culvert inlet. The outlet is actually this area over here on the other side of this pipe. And then the approach, like I had explained before. So, and then again, in determining that erosion severity, it is the height of erosion. So, you know, in this case, you can see that we've got some erosion kind of over here on the right side of the inlet. And so that would be right bank upstream, and we would measure kind of however high this erosion is, however far down it is gone. And then from there, we would divide that by the years that we felt that erosion had been present. And that would give us our value to put into that severity chart to determine whether it was severe or not. So this is an image that visually outlines the severity of different stream crossings in terms of their particular erosion. So the last example that we had was Robinson Drain 3. That is a severe erosion, and likely that was from that right bank inlet side of the drain. So generally speaking, our erosion severities, most of them were moderate, a few of them were severe. Site number 10 here, that one happened to be very severe. Um, it looks like it had been a rather recently redone culvert, and the way that that landscape was designed, there just happened to be a lot of storm water that collected there and fell into the creek, and it was causing a severe amount of erosion in a rather short time. Um, so that is the information on stream crossings. Road runoff, this one was measured a little bit differently, like I had mentioned before. Um, so this captures the likelihood that surface water runoff would go into the creek off of a road. So, in order for this particular type of non-source point pollution to apply, the road had to run parallel with the stream for some considerable length. So, in order to do that, that was a time that we would measure um, the length of that road. So it could be, several hundred feet if the road was that long, and that measurement was taken using aerial imagery. Um, and it also needed to be done in such a way where there was an adequate riparian buffer zone for it to count. Because certainly there's always a time, we can find a road that is parallel to Gilkey Creek, but if that road is, 200 or 300 feet away from the stream bank and there's a park in the middle, that road isn't likely contributing a lot of surface runoff because you've got all of that landmass to kind of buffer and filter out some of that stormwater. So these were cases where you had a road that was running parallel to the creek in very close proximity without any sort of green infrastructure or filtering mechanism to prevent a lot of that point source or that non-point source pollution from flowing into the creek. So this really only occurred at sites 13, 14, and 15. Um, and so when you look at the length of the road, they were quite substantial segments of road that were potentially contributing some of this pollution sources too. And also, some of those roads, they might have had storm drains or something like that used great infrastructure to divert that water directly into the creek. However, given the urbanization of the Gilkey Creek watershed, there are likely a large number of other storm drains that are draining directly to Gilkey Creek. And so the actual road runoff that the creek is experiencing is probably higher than this. However, we were not able to quantify the area of all of the storm drains that we encountered, or to even quantify exactly how many storm drains are throughout Gilkey Creek. And so this is just sort of a brief metric of this, and certainly not a complete understanding of all of the storm drains and potential sources of road runoff that Gilkey Creek is subjected to. Gully erosion, like I said before, this occurred on a few sites, um, and it was really a matter of determining, you know, how much of that water is really digging out gullies that are sort of moving away from the stream, and how much of that water just happens to be like running down the edges of culverts. And so this is the information that we were able to record about gullies. Generally speaking, they had pretty severe erosion potentials. Once a gully starts to be formed, it seems to just grow exponentially quickly, and that's why the erosion severities on gullies seem to be as high as it was. So riparian buffer zones, for the most part, they were generally intact. We had, like you can see here, 5 sites where they were not sufficient based on our analysis. And so this inadequate riparian buffer value, so this is the percentage of the riparian buffer that was present at that site. So at site number 7, we had about 20% of the buffer that we needed, whereas at sites 14 and 18, we had about 3/4 of the buffer that was needed. And then this second row here, the average acreage, that is the average acreage of the landmass uphill of that inadequate riparian buffer that wasn't being properly filtered before that surface runoff entered the creek. Um, so for the most part, we had residential park, school natural. A few of those sites were generally it was just going to be surface runoff. It wasn't necessarily going to be, um, you know, highly polluted surface runoff. But in industrial, commercial, and parking, those areas did have a high potential to be areas that were going to have some negative impacts on Gilkey Creek. Um, so the reason why this matters is because riparian buffer zones, that's really our last line of defense in protecting a waterway from those uphill uses. This happens to be Site 18, so this parking lot was about an acre in size, and as you can see, anything that lands there, there are no curbs, there's no storm drains, there's nothing like that. That water just runs right off. It goes through this very thin strip of grass and then right into that waterway. So trash, motor oil, vehicle fluids that happen to drip off of your vehicle, road salts, those sorts of things, those are all going directly into the waterway without really any opportunities to be filtered. Um, and then just in case anybody is looking to kind of dig into how we went about measuring this, the riparian buffer was measured both by its width perpendicular to the stream, but then it was also measured as a portion of its length for that 100 feet upstream and downstream. So if we only had a portion that was very close to the stream crossing that was maybe half as wide as it needed to be, but it was only 4 feet long, that became an adequate riparian buffer because it wasn't really impacting the creek. That was more just an artifact from the way that stream crossing had been designed. Stream bank erosion. This is really, I think, the heart of the problem in terms of non-point source pollution within Gilkey Creek. So as you can see here, we had a few sites that were slight erosion severity, but most of our sites were either moderate or high. I will like to point out that, as you can see, most of the upstream sites tend to be better, and the erosion severity tends to go up as you move downstream, with the exception of sites 16 and 17. And I would take just a moment and kind of highlight the why behind this kind of weird piece that bucks the trend. So site 16 was actually located along Gilkey Creek between Mott Community College and the Applewood Estate, which is owned by the Ruth Mott Foundation. And back kind of 2007, 2008 timeline, the Ruth Mott Foundation did a multi-million-dollar project to daylight Gilkey Creek, to divert it out of the culvert that actually runs underneath Mott Community College, and then kind of put the stream back onto its historical track. So as part of that project, they did a lot of work installing native plant communities along the edges of the stream, redoing the banks so the banks were stable, they were at a more natural grade, and just generally kind of repairing the health of Gilkey Creek. And from what we can see, certainly credit where credit is due, that project seems to be very successful up to this point. We're not seeing the same kinds of stream bank erosion that we're seeing along most other parts of the creek, and generally the creek seems to be very healthy. With that being said, that would explain why the stream bank erosion in that site is so much less than kind of the other portions of the creek. And we think that that's a great thing, but we also know that that's probably not feasible for everybody along the creek to kind of restabilize their portions. And so with that being said, we do think that there are some other options that can be taken into account to maybe do some smaller things that are also able to have similar benefits in the long run. So, kind of the way that we went about determining the severity of erosion and those sorts of things, we didn't use that kind of metric scale like we'd use for a lot of the other ones. This one was assessed purely by a visual assessment. So did we have bare bank? If there was some bare bank, it was slight. If it was mostly bare bank, it was moderate. If there were bare bank with rills, so rills are like the predecessor to gullies. So you can kind of start to see a little bit of fingers in the soil, and you can start to kind of trace with your hand where the water might flow when it's going into the creek, but they're really not like deep gullies yet. They're not washouts or anything like that. And then very severe was if we had an undercut bank or if we had a washout or something like that. And undercut banks were very common throughout Gilkey Creek, particularly in the downstream runs. Um, so, like I say here, Site 8 downstream. Site 8 was that weird culvert that went for a very long distance underneath Dort Highway and Court Street. Downstream of that, there had been some work done, and they had actually installed some riprap for about 40 or 45 feet. And riprap is like large, very hard to erode pieces like rocks and boulders, and somewhere between like a softball and a volleyball in size. And they're actually put into these kind of cages that are made out of like chain link fence, so that they're not able to wash away and they're too big to really kind of be eroded. And those were set along the edge of the stream to hold that stream bank intact and prevent erosion. So we didn't have erosion there, but there was some infrastructure working on that. Site 14, kind of similar thing. They'd put some erosion boulders in. Site 15, they'd actually one side of the stream bank was just a concrete wall to prevent erosion, because there was a road right there and there really wasn't space to allow for any sort of erosion or that sort of thing. So, and that concrete wall extended beyond the 100 feet that our survey measured. So we didn't actually encounter any erosion there, but that was the rationale. Site 16, that was the Applewood site, which we've talked about. And then Site 17, that entire stream bed from Robert T. Longway Boulevard to Kersley Park Boulevard, that whole thing was just a concrete floor. It appeared that they had put some soil to try to get some native plant vegetation growing on top of it, but a lot of that soil had eroded out. But the erosion hadn't gone outside of that concrete, sort of like the bottom half of a pipe. You could, if you're trying to imagine it in your mind. So that was sufficient in preventing erosion. However, that qualifies as a very highly altered stream bed, and ecologically, that is certainly having impacts on what kinds of, certainly plants can grow there, because there's no soil, and additionally, fish communities and those sorts of things are going to have to interact with that environment in a much different way. So drain tile outlets, we did have these. They were pretty common throughout the survey area. And the way that we kind of assessed severity, we tried to score it. And essentially we built a system where, the presence of a drain tile, that was a point. If there's discharge coming out of that outlet, that was another point. If the discharge had a color or an odor, those were each worth a single point. And then if there was erosion around that outlet where there'd been, a lot of volume coming out, that would be a fifth point. So it was a scale of 0 to 5. Not all sites had drain tiles, so some sites were zeros, and other sites, they had some larger things. However, we didn't. If a site had more than one drain tile, we only scored it by its highest scoring drain tile. We didn't add. If you had 4 drain tiles, that didn't mean that site automatically scored it a 4, because that was just the way that we had to do it. And we weren't civil engineers, and so trying to get into that piece of it, that was a different skill set that was kind of beyond the scope of our intent for the study. So, our data shows that, generally speaking, most of the sites that had drain tiles, they were 1s or 2s on our scale. Site 13 and then Site 19, those each had drain tiles that were showing some additional signs of concern, but nothing that we found to be particularly marked in terms of things that needed to be addressed in a short-term fashion. So our findings and our recommendations, we had a few things that really stood out to us as we were sampling, and then also after the fact in the office as we were doing our data analysis. And the first one, we studied discharge at Site 13 on 2 separate occasions. And so Gilkey Creek, for those of us in the community, for those of us that have seen Gilkey Creek, we know that Gilkey Creek is considered flashy, meaning that when we get a rain event, Gilkey Creek is very responsive in terms of how much water is in the creek compared to how much rain we've gotten lately. That was actually part of the reason why the Ruth Mott Foundation did all of the work along the creek at Applewood, was because when they would get a large storm, the lower portions of that property would flood, sometimes with 7 or 8 feet of water, just causing huge amounts of property damage, endangering historic buildings, all sorts of things. And the reason behind that is because when we get a rain event, Gilkey Creek, the water makes it to the creek so quickly that the creek rises very fast, and then once all that water has been transported out of the watershed, it goes back down very quickly. And that's what we mean by flashy. It doesn't gradually rise and then gradually fall. It's like boom and bust very quickly. And so our particular discharge measurements, the first one was conducted Tuesday, December 13th, and then again 2 days later on December 15th. And you can see here at the bottom of this slide, it shows that we got 0.01 inches of precipitation on the 6th, 0.01 inches of precipitation on the 11th. So when we measured on the 13th, we had basically gotten zero rain for a little more than a week before that date. And so kind of that initial discharge, that is like base flow with no precipitation adding to it. And then we got 0.11 inches of rain on December 15th, which is still a very small amount of precipitation in the grand scheme of things. I mean, we got a tenth of an inch of rain. Most people's, at-home irrigation systems won't even turn off for a rain delay with that level of rain. So, it was a small precipitation event. However, our discharge on Tuesday was about 0.4 cubic feet per second, and our discharge on Thursday was almost 6 cubic feet per second. So that very, very small amount of rain caused a 1,513% increase in our volume of water that was moving through the creek at any, during those two different points of time, which I found to be hugely interesting and also very concerning at the same time. I would like to note that it is unlikely that our second sampling was really conducted at peak flow. So if you look at this graph here, this graph represents in the solid line what an urbanized watershed likely looks like in terms of discharge. And this dotted line is more of a natural watershed. So like I was saying before, this is the amount of water. When it says stream discharge, this is the amount of water that is moving through the creek at any given time. And then this is, time since our rain event. So if this is the rain event, in an urbanized watershed, that water gets moved through storm drains and other gray infrastructure very quickly. And so the stream very quickly fills up. And then the stream is efficient and it moves all of that water out very quickly, and discharge drops back down very soon. In more naturalized watershed, it takes time for that rain, that precipitation, to work its way either across the landscape or through the ground to get into the stream. So whether that means that it's being slowed down by running through grass and weeds and trees and those sorts of things, or if it's sinking into the ground and then it's slowly working its way through, and then it's, sort of seeping out of the ground into the creek, all of those processes, that slows it down. And so the stream has to transport the same amount of water in both instances. But in an urbanized watershed, it does all of that work very quickly. So you get a huge volume of water that's moving very quickly. And then in a more naturalized watershed, you're getting a smaller volume of water. It just takes it a much longer time to do it. And so this 1,500%, it's unlikely that I sampled the second time up here at the peak. It's more likely that I sampled somewhere in this range or in this range. And so our peak is likely going to be significantly higher than even this 1,500% increase. But that level of detail is going to have to be sort of quantified in a different study, because that was a bit beyond the scope of what we were trying to do. But the opportunity to measure this and to kind of create that benchmark baseline presented itself, and so we did. In terms of, our data from our impervious surface study, that kind of initial GIS stuff that we did at the start, looking at the acreage of our large sites, this runoff volume, this was calculated using what the National Oceanic and Atmospheric Administration, NOAA, their kind of projected 2-year storm would look like, which is a rain event where we get about 2.3 inches of rain in a 24-hour period. So if we get 2 inches of rain within 24 hours, you know, that last site that we talked about, that former cinema, that's 17 and a half acres, that would produce a little more than 132,000 cubic feet of water. And so if we could trap that water, if we could hold that water on site, if not permanently in rain gardens and those sorts of things, but at least hold it on site for a few hours to prevent that from going directly into the stream. That will help to kind of you know shorten that hump in the graph and stretch it out quite a bit, to really reduce that overall burden that we have, um, on our stream system as a whole. Because when you really kind of get into the nuts and the bolts of it, when you get all that water that's quickly moving through the creek, you really run into a situation where, because we've got a lot of fast moving water, it's just able to erode that much more material. Kind of think about it, if you know, if you are drinking a glass of something cold in the summertime and you put a little bit of sugar in there, you kind of got to stir it up. Once that liquid starts moving, it has the ability to erode that sugar in the bottom of your glass a lot better. And so essentially, every time we get a rain event and we're channeling all that water into the creek at once, we're just stirring up that creek, and we're pulling all of that sediment out of the banks, and we're washing it downstream. And so if we can try to reduce that as much as possible, we will be, as a watershed, in much better shape. And so, if we can try to de-pave, if we can try to, add in some other types of green infrastructure, hopefully we can reduce some of that flashiness, and we can start to slow down a lot of the stream bank erosion. Um, you know, Overall, our survey demonstrates that the severity of erosion and pollution in the stream, um, really, really warrants further attention. It warrants, doing a bit more, work to clean up and protect the stream, but also to kind of rethink the way that we, as residents of Gilkey Creek, how we are managing our own personal stormwater and those sorts of things. So whether that's, you know, putting some consideration into diverting water out of your downspouts, that might flow into a storm drain, and kind of pushing that water out into the lawn where it can go back into the ground, or if that's, working with your community to, try to tackle a bigger project. Every little bit counts, but we really need to start thinking about this, I think, a bit more. Um, we are confident that this study has done a lot to provide a baseline of, what is the condition of Gilkey Creek now in 2020. And so as we are working in the future, we'll be able to compare, a lot of the same data that we collect then with what we have now, and we'll be able to really quantify how much good are we doing. The amount of urbanization within the Gilkey Creek watershed really seems to be having, a very tangible, very measurable impact. And we think that the work that we've done here will hopefully give us, the opportunity to try to correct some of those things. So I hope you folks have learned a bit about the Gilkey Creek watershed. And if you have any questions, feel free to reach out. Um, the Genesee Conservation District is always welcome to host groups and to, work on projects that improve our local natural communities. So thank you for your time, and we really appreciate it.